Hello, everyone. Boy, this is quite nice. My name is Venk Shukla, and I'm really, really happy to introduce the dynamic leaders of the cloud track. It's so good to be back in person after 3 years. It's so good to see a hall full of people, especially the people that we otherwise don't get to meet. So please give yourself a round of applause. It's a very interesting track. All the hottest issue in cloud is will be presented to you. And to give you more detail, I'd like to introduce the two dynamic chairs of this track, Janaki Kautha and Pradeep Nair. Would you please come to the stage? Thank you very much.
Thank you, Venk, for kicking us off. You are a legend. Thank you for guiding us. And I welcome you all to the Cloud Track. It's a beautiful afternoon. I really appreciate you taking time to be with us today. And this event wouldn't be possible without the sponsors. We have two amazing sponsors for this track, particularly VMware and CXApp, and TiE team, leadership, and the Cloud Track team. We're really, really appreciative of that. And thank you. And before we begin, I really want to thank all the volunteers for this track. For the past 3 months, we've been working really hard to identify an amazing speakers and countless number of going back and forth, curating this track. And I want to thank all the volunteers. Without them, we won't be here today. With that said, we have some amazing diverse panelists here. And Pradeep is going to introduce the keynote speaker.
Hello. Thanks everyone for coming. I think we got a lot of agenda lined up, so hopefully we won't have time for a lot of Q&A, but you guys can meet offline and talk to people. I think the first keynote is Sanjay, a former colleague of mine, and Sanjay leads the Service and Edge portfolio business at VMware. I'm excited for all of us to hear what VMware is leading in terms of innovation for the next generation Edge, and Sanjay is the best person to talk about that. Welcome, Sanjay.
Thanks, everyone. It's actually pretty exciting to be here and to see people like Vish and Venk who have really set the stage for a lot of the innovation that has happened in the Valley. So in the next 20 minutes or so, I hope to cover what is going on in the cloud and edge track, because one of the things that's happening that we have noted at VMware, which is following the applications, is that the applications are growing faster and fastest outside of the main public and private data centers. So I'm going to cover what that is, what's the definition of edge. And as Pradeep said, I run the service provider and edge business. Now that might seem like, what does that mean? So service provider really means telecom, but telecom people don't like to think of themselves as telcos anymore. They like to think of themselves as software companies or techcos. So that's one piece of it. And then the edge, which is, like I said, everything that's outside of the main public and private data centers. All right, so let's dive right in. Now, all right, so like I said, workloads, which is what VMware follows, are growing fastest at the edge. Now, the bulk of the workloads are, of course, in the private and the public data centers, but they're growing fastest at the edge. And because we follow where the workloads go and we lay our digital infrastructure where the workloads are, so this focus of looking at things that are outside of the private and public data centers is what the edge is all about. Now, if this seems very complicated, there's only two things really you should remember. The first is the Rolling Stones song that's called Get Off My Cloud. And the second is the Aerosmith song that's called Living on the Edge. So if you remember just those two things, that captures everything that you should know. The rest of it, you can now look at all your phones for the rest of my talk. So when we look at this, it's very important to define what is the edge, because there's many, if you ask 10 people what the edge is, you'll probably get 20 different answers. So we decided to come up with a very simple taxonomy for what the edge is. So it is distributed digital infrastructure right? That's important because it's digital, you know, the whole digital transformation thing, and it's for running workloads. And these workloads are a diverse set of workloads that I'm going to cover in this conversation across a number of locations, which is also very important. And they're placed close to where the endpoints are producing or consuming data. And there's a diversity of endpoints. So this covers everything of what happens with the edge. And then along with this, there's a taxonomy that says far edge is on the premises of the end customer, and the near edge is at the first point of aggregation. Okay, so you remember these two things, far edge and near edge, and then this is how the telco comes in, or the techco, and the enterprise, and how this all pulls together. All right, so what's our approach to the edge? The first part of the edge is what has worked in the cloud is not going to work at the edge. And the first piece of this is just simply what the size of that digital infrastructure is. If you look at what is needed to run in the cloud, whether public or private, the digital infrastructure tends to be fairly large. So the first thing we need to do to run digital infrastructure at the edge is to thin out the stack. So I tell my team, some of whom are here, is that any one of them should be able to stand up and say, honey, I shrunk the stack. That's very important. So you need to shrink the stack, bring it down so that it runs close to the edge. And now, because of the issue with energy consumption, whether it's in Europe, Asia Pacific, or even here, we need to tend towards 0 watt. And one example is if you look at what's happening with telecom, 70% of the energy of a telecom operator is in the radio access network, in the RAN. So in those cell sites, of which there are tens of thousands, sometimes even hundreds of thousands. So reducing the footprint of what happens at the edge and then running it with much smaller wattage is really one of the key things to get done. The second thing to get done is to automate, and I'm going to say a few more things about why this automation is so important, but it's really related to the number of locations that you have. You cannot afford to have any human being touch those locations. As soon as you do that, your business model is out the window. So the automation is absolutely critical. And the third piece is the zero trust. So it's 0 watt, 0 touch, and 0 trust. These are the elements. Now the last thing is to make this edge programmable. And what that means is today when we look at networking in particular, you get a certain number of bandwidth, like you say, okay, I get a gigabit per second and you got to pay $50 or $100 or whatever. But it's not programmable. It's not like I have a particular application that needs to use more, I'm willing to pay more, but I will pay less for the rest of the applications. It's actually very static, it's not dynamic at all, and us networking people get very excited when people say network on demand. So this make the edge programmable is all about network on demand. So this is what businesses want. I've put enterprises up there. But really, you cannot have an edge without talking about the network, which is why the service provider or the telco comes in. And there's really two pieces to that are very important. The first is that the telco network itself has not been modernized. So if you look inside a telco network, you were to go to one of these cell sites or you were to go to a central office, it really looks like radio infrastructure with a little bit of software put on top and a lot of hardware. That's what it looks like. It looks quite dissimilar to what happens in a data center. But the battle between the telecom architecture and the compute architecture has been finished. And the computer people, most of you in the crowd, have won, right? So it's really the compute part of this infrastructure coming in and disrupting what's going on in the telecom network. So modernizing the telecom network is the first thing, but that's not sufficient. If some of you were in Barcelona, there was a big debate going on about fair share. All the telecom operators complaining that they spent so much money in upgrading their networks and they've got 5G and all this coming in, but the over-the-top people are skimming out and taking all the, not just the revenues, but the profits with them. So now there's this rebalancing that is going on, and Europe is first because Europe has probably the largest density of operators out there. So, when you have a market that is not growing that fast and you have a large number of incumbents in there, of course everyone's profit is going to go down. So there's this battle going on. Watch this battle. It's a very crucial battle because out of this battle will come some resolution, and that resolution will pave the way for monetization. So telecom operators want to monetize the network, and today's static network, which is just simply pay $50 for a gigabit per second, that's not monetization. That's not enough. Everyone has come to the conclusion that simply going after the consumer is not going to solve this problem that it has, and we all need the connectivity. We cannot survive without this connectivity, whether we are a business or whether we are consumers sitting at home. Okay, so that's basically the framework that I want to talk about. So let's look at 3 different examples now. The first is on the manufacturing side. If you were to go into a manufacturing floor, and I've spent a fair amount of time in the last 9 months or so visiting a lot of the manufacturing, particularly around automotive, you were to see a number of machines on the floor. These machines have the hardware, software, and the application all locked in together, and it's pretty much proprietary. If you want the machine to do something different, then you've got to go ask the person who makes the machine builder, to change the feature of the application. And that usually is a year to year and a half to 2 year cycle. So we are starting with working with these machine builders. Siemens is one example, and they're looking at taking what used to be a physical device called a PLC and virtualizing it. So now you see these vertical lines over there. We're going about making them horizontal, because really what VMware is about is making that horizontal digital infrastructure. When you make that horizontal digital infrastructure and people trust that infrastructure, then they will virtualize their applications and put them on top. When they virtualize those applications, innovation results because smaller companies can get in. They don't have to build this entire thing from top to bottom. So this is what's afoot in manufacturing. Very exciting, and one of the first companies that is going about doing this is in Europe, one of the large auto manufacturers, and we are working with the machine builder community to get this thing virtualized. So that was the before, and this is what the after looks like. Okay, now what the after is, you see this thing called edge compute stack. That's that horizontal infrastructure. You take those machines and the application that the machine runs, you run it on that edge compute stack, and now this looks very dissimilar to what happens with IT. This is called OT, or operational technology. This is where the OT person gets pretty excited, because now if they want a new feature, they can use the computer part of the pipeline. Most of you are familiar with CI/CD. So you can run a CI/CD process to change the nature of the machine that is running on the factory floor, to change what it does in almost real time, when previously you had to wait a year or year and a half. This is going to result in a massive increase in productivity, and this is just on the factory floor. I'm going to show you an example of what happens also inside the vehicle itself. So this is one part with this example of what's going on with an edge compute stack that is running on thousands of locations. One of the factories I visited had 15,000 endpoints in the factory. So there's a technician standing there with a Stanley screwdriver, and he presses the screwdriver. He needs to get haptic feedback within 200 milliseconds or so. Otherwise, he's not going to turn the screw to the right amount. So this kind of networked system can run very efficiently on an edge compute stack, and the next time you want to have a different machine, not a screwdriver, you can still run it because it's just simply a change of software. Very exciting in this space. The next example I want to give is from the is a telecom example. Now all of us, of course, are familiar that in the United States, there's AT&T, there's Verizon, and there's T-Mobile, right? Those three. But there's a fourth operator now, and that fourth operator is Dish. The same folks who are doing the satellite, now they're entered into the 5G space. And the exciting thing that they've done is they are coming at it with a completely disaggregated system. This disaggregated system is called ORAN, for Open Radio Access Network. Now, if you were to go to one of the cell sites that Dish has deployed and you were to look in, it doesn't look like a telecom equipment site. It's got standard off-the-shelf platform from either Dell or Supermicro. It's got VMware software, and then it's got these applications on top. The applications are not applications that you and I are familiar with. They're not applications for consumers. They're not applications that you would use for enterprises. They are applications to actually run the 5G network. But this is just simply very similar to what's happening on the factory floor. So what we're doing is disaggregating the cell site. We're putting in a layer of software, and now you can imagine that you need an application to run the 5G network, but you can customize it. You're not locked into one particular provider for running the 5G network. You can have different customizations depending on who you are, and I'm going to cover a couple of examples as we move along. Now, important thing here, you'll notice at the bottom of this slide, it says 40,000 sites. So we have crossed about 12,000 to date. We're going to get to about 24,000 in a few months. So you have 24,000 sites at which there is this digital infrastructure. The important part here is, for those of you who've seen the movie Everything, Everywhere, All at Once, Everything, everywhere, all at once. This is what we need to do when you have a number of locations across the edge. You cannot afford to say, I'm going to start upgrading this edge, and then, a year later you get to the 24,000th edge, and then you start all over again. That cannot happen. So this everything, everywhere, all at once is really what needs to get done in order to get a problem like this solved. And when this disruption happens, then you're going to see this disaggregation occurring across all the radio access providers and also in the core of the network. And this is extremely similar to what's happening on the factory floor. So this edge cloud idea that you take this digital infrastructure, distribute it around, put a layer of software, put the applications on top is really central to this idea. Okay, let's move on to the next one, which is SASE. SASE stands for Secure Access Service Edge. So here's an example of, let's say, a retail customer. Okay, a retail customer in Indonesia, there's a company called Alfamart, and they have 15,000 locations across all of the islands in Indonesia. And they deployed this technology, and now instead of having routing software and the software for VPNing and the software for access running on top with these proprietary boxes, they're just simply a layer of software, and you can deploy 10,000 of these in less than a span of 9 days. So this is getting to that point of everything, everywhere, all at once, done at the networking layer. And this is done for security, done for networking, and the next thing that's going to happen is it's going to be done for compute as well. All right, I want to give you this example which I alluded to a couple of times in terms of what's happening not just on the factory floor and in the cell side, but also this is an example of what's happening in a car. So this example comes from the UK. This is the Surrey and Sussex Police. And what these folks want to do is they want a dissociated system that is running in the car. Dissociate meaning you can't mess around with the electronics that are to run the car itself, right? Because if there's some issue that happens over there, you don't want the car to stop. So this is an overlay technology that is running on a different set of computers that are running in the car. And there's a set of applications that they want to run here. Again, workloads are important. These applications are important. This is for the police force. So what happens here is the police officers are driving around in the car, and they have one application, I'll tell you, is ANPR, Automatic Number Plate Reader Application. So the streaming is coming from the cameras. The cameras are recognizing the number plate. They're going back to the base station. They're figuring out who is this person in the car and whether the police officer should take some action or not. Now, it's not really quite real time. And I, whether fortunately or unfortunately, happen to be in one of these cars while they're doing a ride along, meaning that they're actually on the police, on the beat. So I sit in the car and it's all fine and we're chatting and everything. There's two police officers in front, and all of a sudden, boom! I mean, it's just they get a call on the thing and they're just off. They take both sides of the road and they're responding to a call that's come in to go to a crime scene. When they're doing that, they're looking at all these cars that are close to the crime scene. They're trying to correlate it with the video feed that is coming from a helicopter on top. And you can see that these folks can be really helped with technology that you and I produce. Because the feed is not real time, it's not correlated enough, it's too slow, you can't go all the way back to the cloud and come back with that ANPR result. You want it right there. So you want that application and the data to be cached in the car or to the first point of aggregation. And this is where, again, this edge technology comes in. Because you cannot go all the way back to the cloud, so you need that technology. Again, here it's an edge compute stack. The ANPR application runs on top. There's a digital forensics application that runs close to it. It runs over that SD-WAN layer that I spoke about, and here it's bonding 4 LTE connections to get that real-time conversation back. So we got to that crime scene, and then I went to unlock the car door to get out, and they turned around and said, you sit right there. So, because I wasn't wearing a bulletproof vest, so I said, okay, fine, I'm not getting out of this car. But by the time they got back, whatever they were, there was some domestic violence crime scene that they were going out and addressing. But this is an example of where we technologists can help people like this. Now I wanted to talk about one area. The last piece of this was the programmability. Where does this programming come in for the edge? So I'll give you a couple of examples. The first one is this coronation is going to happen in the UK, right? On the 6th. right? I'm not a coronation either expert or aficionado by any stretch, but the important thing here is for the network itself, Vodafone is going to set up a sliced network for the coronation. What does that mean? That means that the same physical network that they have, they're going to set up a specific part of that network in software just for the coronation. So if you go to the coronation, you're going to get a slice of a 5G SA network. This is network slicing. Okay, so this is not as static as I spoke about, but it's still really not dynamic. What we want to get to is a completely dynamic network. And an example of this would be that police officer that is driving around. Would they pay $20 or $50 to get a special slice at 4K to correlate what that helicopter is sending of the crime scene along with the reading of the ANPR application so they get a better view when they land up in the crime scene? And we think yes. We think absolutely. I mean, they're saving lives out there. They would pay this much. And this is just one example of a dynamic network on demand that would come together across all three layers of the stack, the compute layer, the networking layer, and the underlay. Another example which might be more interesting is if you're watching IPL, or you watch the Soccer World Cup, or you're watching the Super Bowl, or of course now you're watching Warriors and Lakers. Now, my kids happen to be in that generation Z, X, Y, I don't know, the 20-year-olds, and they go there to watch these games, but they don't go there just to watch the game. They go there to show their friends that they're there watching the game, right? So, you go to a Super Bowl, pay $2,000. Would you pay another $50 to get a pristine 4K slice when a touchdown is scored? And we're betting that, yeah, they will. Now, at the last Super Bowl, the 5G network was not good. People tried to get on. They couldn't really send these streams. But if this network was sliced, if it was network on demand, and the application was running all the way at the edge, you had the tariff available, we think that it is going to happen, and we are just at the beginning stages of this next revolution that's going to happen at the edge based on cloud-based technologies. All right, so I want to end with a couple of things, which is the importance of that energy part that I spoke about first. So 70% of the power consumption of a telecom operator is in that RAN. If you're able to save even 1% or 2% over there, it's going to have a massive impact on the overall energy consumption. And Europe in particular, this year, was extremely sensitive to what is happening there, right? So, there were some of the operators there, including OBS, that were shutting down some cell sites because there wasn't enough energy to run them. So what we're going about doing here is, again, adopting this digital infrastructure, and now the applications that are running on the RAN are not just to get you that 5G signal, but they're actually to control the RAN in real time based on where you are, what kind of signal you want, who are you trying to get access to, which cell sites are available to you. This layer is called the RAN Intelligent Controller, or the RIC layer. And there's a whole host of small companies, and I'm sure some of them are here at TiEcon. These are startups that are putting applications on top of this infrastructure layer so they can control how this RAN works based on real-time traffic, based on the tariff, and based on what is available for them to control. Now that is going to result in much better spectral efficiency, so you don't have to turn on, as an example, all of the MIMO radios inside that cell tower depending on who's getting access or who's not getting access. Extremely exciting space. It is important not just for carbon reduction, it's definitely important for power savings, just to keep not the lights on, but to keep the signal on. All right, so of course I need to talk about the products we have too. So otherwise my marketing people are not going to forgive me. So the three layers of the stack that I mentioned. First is the bottom layer, or the underlay. This is how you control the radio access network, how you control the core, and how the computer side of the industry is winning. They're winning because compute technology is coming in, it's disaggregating, we know how to do much faster feature velocity. As long as we can figure out, of course, the zero trust security angle of it, then we can have a CI/CD pipeline, we can control how the radio access network works, and each one of us can have a slice of the network that we pay for, depending on what we're doing with it. So more important things you pay more, less important things you might pay less, right? So all of this, we have a platform that we call the VMware Telco Cloud Platform. that we sell to service providers to get this done. The next layer on top is our SD-WAN and our SASE layer. This is the layer that programs the underlay. So that's the one that understands the application and then tells the telco cloud platform, give me this slice or give me this other slice, also capable of aggregating the underlay network together so that you can have one pristine connection for the application that runs on top. And then the last piece is, of course, the edge compute stack, the examples of how you have ANPR or digital forensics. I just gave you manufacturing examples, but there's examples from retail, there's examples from energy, where this entire revolution is going on of using cloud technologies to come in all the way at the edge. And these are the three layers of the stack. We think that this is going to set all of us as an industry up for the next 5 years, 10 years, or a decade. And it's not just what is happening in the main data centers, in the private or the public clouds, it's happening everywhere else. It's happening at the edge across these millions of locations, whether it's in the RAN, or on the factory floor, or in the retail store, or in the substation. All right, so I want to end with that. I want to thank you all for, just a recap, thank you all for giving me the opportunity to come and chat. I want to thank the two co-chairs for doing such a fabulous job. And, this is a great venue to be. And of course, thank you, Venk, for recognizing that since we are in this together and meeting in person, it's a whole lot different than being at the end of an electronic connection.
You can stay here.